This is a video lecture for Math 181 for Friday, April 24th. And this is part one of this video lecture. The topic today is calculating areas between curves. In chapter 5, we learned how to do integrals. In chapter 6, we're going to apply integration to a number of applications. And this is the first application. What if we have two curves and we want to find the area between these two curves over some interval AB? In other words, what I want to do is I'm going to shade in, the area we want to find here. So I want to find this area right here, the area enclosed by these two curves between A and B. And it's important to note here that over the interval AB, f of x is greater than g of x at all points. And that's important because we don't want these curves crossing over the interval of interest, because that will complicate our area calculation. So the assumption is that one of the functions, f of x, is greater than g of x over this entire interval AB. And we want to calculate the area here. How do we do this? Well, our approach is similar to chapter 5. What we're going to do is we're going to divide this region of interest into a series of rectangles. And the width of each rectangle will be delta x. And this point here is x sub I. That's point x sub I. And then I'm going to draw just one of these rectangles here, like this. And we know the width of this rectangle is delta x. We're going to divide this curve into a series of rectangles and add up the areas to get the total area. How do I determine the height of this rectangle? And the height of this rectangle is simply this distance right here. How do I determine that distance? Well, let me use a different color pen. This distance right here, this overall distance, this distance right here is simply f of x sub I. So it's our top function evaluated at x sub I. Okay, let me use a different color pen again. This height right here, what is this? Well, this is simply g of x sub I. This is the function g evaluated at x sub I. What is this height of the rectangle here? Hopefully you guys can see the height is simply f of x sub I minus g of x sub I. So this height is f of x sub I minus g of x sub I. Okay? And that's the way we calculate the height of each rectangle. And using this idea that the area is the sum of these rectangles and the limit as the number of rectangles goes to infinity, the area between the curves will simply be the limit as n goes to infinity, I to 1 to n. The limit is n goes to infinity of the sum from I equals 1 to n of the area of each rectangle. Now keep in mind the height of each rectangle is f of x sub I minus g of x sub I. And then we multiply each rectangle by the width, delta x. Okay. But what this is actually the definition of the definite integral of this function right here, which is f of x minus g of x. So this area simply equals the integral from a to b of f of x minus g of x, okay, times dx. This is simply the definition of a definite integral. So to find the area enclosed by these curves between a and b, we're going to integrate over our interval, integrate from a to b of f of x, the upper function minus the lower function, f of x minus g of x dx. This is the theory behind calculating areas between curves. Now we're going to consider three examples. I'll do one example in this part, and in the next part of the video lecture I'll do the other two examples. Okay. Example 1 is the following problem. We're interested in finding the area between these two curves, y equals x squared plus 1 and y equals x on the interval of 0 to 1. Okay, we're interested in finding the area between these two curves on the interval from 0 to 1. A good idea in doing these problems is first to create a quick graph. Nothing super elaborate, but let's just create a graph of these two functions. Now, x squared plus 1 is actually a parabola that is shifted up by 1. It's a regular bowl-shaped parabola shifted up by 1. So I can graph this guy like this. This is x squared plus 1. And then we can graph y equals x, which is a line, right? Which is a line that looks like this. Okay, and it goes on like this. And what we want to do is find the area enclosed by these two curves between x equals 0 and x equals 1. So in other words, I'll fill this area in. We're interested in calculating this area right here. Okay, we want to find that area. We're going to use our formula we just found. The area enclosed between these two curves is equal to the integral from 0 to 1 of the upper curve, which is x squared plus 1, minus the lower curve, which is x, okay, times dx. All right, now we can simplify this integral. This is 0 to 1 of x squared plus 1 minus x dx. I'm going to reorder this. This is the integral from 0 to 1 of x squared minus x plus 1 dx. And now we're talking about the integral of a simple polynomial. And we can do that very quickly. The area will equal x cubed over 3 minus x squared over 2 plus x, evaluated from 0 to 1. Let's plug in our limits of integration. We get 1/3 here. We get minus 1/2 here, plus 1. And then we plug in 0, minus, and everything, this will all be 0. If we plug in 0, we have all x's here, so we just get 0. So this equals 1/3 minus 1/2 plus 1. And you guys can do this a couple ways. You could find a common denominator, but basically I'll skip that step. If you guys want to do that, you can. Common denominator is 6. So this is 2/6 minus 3/6, which leaves minus 1/6 plus 1. This equals 5/6. So this is the area enclosed between these two curves between over the interval 0 and 1. Okay, in part 2 we'll do 2 more examples.